So Ben, we're in the Climatic Wind Tunnel. It's currently set to -10 degrees.
Yeah, absolutely. That's fairly mediocre for this wind tunnel. It gets down to -35 if we push it.
Okay.
It's our second wind tunnel. So we've got two. This one is for our commercial vehicles. So it goes from -35 up to 50 degrees. Okay. So we can do either cold testing, hot testing, or sort of ambient drive cycles. The first wind tunnel is our passenger vehicle wind tunnel, and that does a lot more high-speed wind testing for passenger vehicles and electric cars such as this.
So Ben, we're sat in here, it's -10 outside. What are the benefits that we can get from doing that?
So a lot of the benefits for our customers is that they can run climatic tests, so at very cold, -35 up to 50 degrees, without having to ship their prototype vehicles or their production vehicles around the world. So it saves a lot of cost, a lot of time, and there's also a lot of repetitive testing that you can do, which you just can't find out there in the weather.
You can't always guarantee it's going to rain or snow.
Exactly. Or the temperature, so it can fluctuate. So in here we have very precise conditions. They're very repeatable every time.
We've also got LCV coming up. You're going to be presenting on our booth.
Yeah, so I've got a thermal presentation that I'll be giving on the booth that's mostly based around electric and hybrid vehicles. The amount of energy that we can save or reutilize from the thermal system, and how that can extend the range, or it can create a more efficient vehicle. So that's the reason that we're in this wind tunnel. So we're doing some tests here in cold conditions, and we can also then do that in hot conditions as well.
Okay, great. Looking forward to it. It's really cold in here, so I'm going to put on the heated seats and the air conditioning as well, try and bring the temperature up.
Bring it a bit warmer.
But obviously that is something that impacts on the battery.
Yeah, absolutely. I mean, that's a fairly standard test that we do here. So we get the vehicle really cold, we soak it in the wind tunnel at very cold temperatures, or we do the reverse and we do it at very hot temperatures. We've also got a solar array, and we can bake the vehicle as if the sun was baking it. And then we'll turn the air conditioning on, or we'll turn the heating on to try and raise or lower the temperature of the vehicle. We can then plot that, and we can understand how quickly the humans will get to a comfortable temperature. Traditionally, they used to measure the temperature in various areas of the cabin, but nowadays we're moving more and more towards comfort, because that's the actual attribute of the human. And that's the reason we've got this guy in the back here. So he's our human mannequin, our thermal mannequin, and he measures the temperature, but he's also got a lot of algorithms and control software in the controller, and what that does is that calculates the temperature, but then it relates that back to a correlated human comfort model. So you can actually take the temperature, but then understand how hot or cold that person will feel. So it's very useful when you've got things like your glass and your radiation, and you put your arm on the windscreen. The sun will actually make your arm feel a lot hotter than the actual temperature at that point. So the human modelling is really important.
Oh, that's interesting. And presumably then, if we're talking about how much load we take from the battery when we're putting this kind of systems in, maybe people are starting to get a little bit anxious that having the air conditioning on means they can't drive as far.
Exactly. Yeah, so if you have your air conditioning on or your heating on, that's one of the big draws of the power from the battery. At the moment, a lot of the legislation, the certification is done, but it's only at 23 degrees, and that's with none of the air conditioning turned on. So as soon as you drive off the forecourt with your range that's published, if you go into a cold condition or a hot condition, anywhere outside of 23 degrees, or you turn your air conditioning on, you're going to be drawing a lot more energy from your battery than the published range from your manufacturer.
Right, okay. And also there's an element of actually engineering those batteries, so making them more efficient based on this kind of data that we're pulling out from the car. Yeah,
absolutely. And it's not just the battery as well. So we can do the thermal management of the battery, and we can model and simulate that. But what we can also do is take that a step further to the system level, and then to the vehicle level. And we can look at the full holistic efficiency of the entire vehicle, and we can look at how all of those systems interact. So we're doing that at the moment with a lot of simulation. So we take the vehicle in a wind tunnel at the moment, we benchmark it, that data is fed into our simulation models, and then those simulation models predict where the losses are, how we can efficiently recuperate some of that energy, reuse some of that energy, and then all of that extra energy then can then be either stored in the battery or go to the motors, and that sort of translates into either extra range for an electric or a hybrid vehicle, but also extra comfort, so you can get to a comfortable temperature more quickly.
You just mentioned benchmarking.
That's
something where we presumably collect a lot of data. and use that within our engineering solutions?
Yeah, absolutely. So recently we've actually just done a benchmark program for a tier 1 overseas, where we've actually taken an electric vehicle, we've stripped it down, we've loaded it with sensors, we've taken that data, and then we've created a simulation model of that vehicle, so they can then understand the difference if we were to swap out some of their components into that vehicle, and what the effect of that is on electric range or performance.
Okay, so that gives them a way of perhaps testing things within computer simulation rather than actually having to do multiple prototypes within the vehicle itself.
Exactly. So we can do multiple simulations, which is a much quicker, cheaper option to try out different technologies, and it also gives them sort of a sales tool that they can then go to their manufacturers and say, we've done this simulation, we've correlated it to a real vehicle in a wind tunnel, and because of that we can then extend your electric range, or we can increase the performance of the vehicle, or we can make the air conditioning warm us up a little bit faster.
So Ben, one of our core values here at HORIBA MIRA is making journeys cleaner. How does energy efficiency sit into that?
Yeah, so our energy efficiency group is working very heavily in the electrification domain, so both electric and hybrid vehicles. So we can take vehicles and benchmark them at the very beginning of a customer's program. We can do all of the simulation, the model-based design, and the physical build of those systems on one of our other rigs, and then we can do the final validation in one of these facilities.
Okay, so it's a full end-to-end solution.
Yeah, absolutely, it's really end-to-end. Yeah.
Okay. Ben, I think we spent about enough time here in a climatic wind tunnel, but for those people who do want more information about the kind of services we offer in energy efficiency, what's the best way of finding that out?
So there's two ways really. You can either lodge an inquiry through our website, there's lots of information on there, but we also post quite regularly on social media, and they can get in touch that way as well.
Okay, great. Thanks very much for the information, and look forward to seeing you at LCV.
Thanks a lot.